So this is my capstone project. This is the AutoML screen. I decided to go with the Titanic dataset. So it's a classical dataset for machine learning, where the objective is to predict if a customer will, the passenger will survive the crash or not. So first, I imported the dataset. I loaded the dataset in Azure ML. Then after loading the dataset, I then looked at the columns in the dataset just to make sure that the data is fine. So I put the dataset into a pandas data frame. From there, I imputed missing values. So age, embarked, and fare, they were missing. So I imputed missing values with the median, mode, and the median and the mode. And you can see now when I look at the data types, there are no missing values. Then I dropped columns which I deemed they were not useful. So passenger ID, cabin, ticket, and the name. I feature engineered one column called family size. From there, I encoded the numeric columns so that the categorical columns so that all the columns are numeric. After that, I then created my compute cluster ready for training the model. I split my dataset into train and test. I then made sure that I've converted so here it was giving me an error if it was still a data frame. So I had to convert it back into the dataset that Azure ML can work with it. After that, then I set my configurations. As you can see, so it was a classification problem. Our role is to predict the column called survive. So I built the classification model, and you can see the run was successful. So our best model was the voting ensemble. Then from the voting ensemble, what I did next is I then saved the model using pickle. So I used joblib, I pickled the model. Then I went to deploy the model. So you can see I was able to deploy the model, and I even supplied inputs. I was able to generate the scoring URI, as you can see here. Then from there, I keyed in a test set. So you can see the variables that I used just to see if I can get a prediction, and the model was having right. As you can see, based on that data, the response code was 200 and the predicted value was 0. And then this just shows that the model was able to serve well. And then after getting the logs, what I then did is I deleted the service. So when I went again to the hyperparameter tuning, so same thing applied, though I didn't deploy the hyperparameter model because I'd already deployed the initial model. So I just loaded the training dataset that I had because I'd already cleaned it. So I specified my cluster again. Then I set my hypergraph configurations. I tuned the parameters there. I specified some parameters that need to be searched. Then I ran the model. As you can see, a couple of models were here. So I ran the models here with the run ID. So the best model here was the run ID HD 1909, accuracy of 0.86, and those were the best parameters. And then I saved my model. So I covered everything that was expected in the module. I then went ahead to update my GitHub profile, which I'll be updating the README. Thank you.